Hello, this is Jennifer Martinez, and in this video I'm going to talk about the salt in ocean water. By the way, this is an application to log functions. So let's go ahead and read the question. So suppose you have the following function, f of x equals 33 plus 1.3 times the log of x plus 1. This f of x models salinity of ocean water to depths of 1,000 meters at a certain latitude where x is the depth in meters and f of x is in grams of salt per kilogram of seawater. So they're asking you to approximate the depth to the nearest tenth of a meter where the salinity equals 36. So first let's go ahead and write this equation down. What does f of x represent? Well, it says right here that f of x models the salinity of ocean water. So I'm going to go ahead and write that down. By the way, the units, they also tell us right here, f of x is in grams of salt per kilogram of seaweed. So let me go ahead and write that down. And what is x? X is... oh, there it is. X is kind of hidden, is the depth, let me go ahead and erase this, is the depth in meters. So let's go ahead and write. Okay. So the question again asks, what is the depth? So this time they want to know what is x when the f of x is equal to 36. So all I'm going to do is I'm going to plug in 36 for my f of x and find x. By plugging this in, rewriting the right side, not changing that, but changing the f of x is equal to 36. So how do we solve a log equation? Well, the first thing I want to do is isolate the log. So I'm going to subtract both sides by 33. I'll get a 3. Now I'm going to divide both sides by 1.3 and rewrite that. Now, I would like to get out of logs. By the definition of log is an exponent, so all logs can be written as exponential form. And the base, when there is no base, this right here is a base 10. Base 10 is what it means when there's no written base. So that means I can rewrite this as, let me write it over here, base 10 to the exponent. So this whole thing, the thing that's alone is the exponent. So it's 3 over 1.3. And you can go ahead and divide that in calculator. But it's best if you just leave it so that way you don't have to round in the middle. Equals the inside. Again, this is the base. This is the exponent. So that's why I made the base 10 and the exponent 3 over 1.3. Can we subtract both sides by 1? And that would be the value of x. So let's go ahead and plug that in our calculator to see what we get. If you're going to plug this in your calculator, one way to do it, if you have a caret as an exponent, on your calculator you can put 10 raised to the parentheses 3 divided by 1.3, subtract 1. If you don't have a parentheses and you don't have a caret, you're going to have to do 3 divided by 1.3 first, then take 10 raised to that number and subtract 1. Doing this, what I got is 202.091761 is the farthest my calculator goes out, and they ask you to round it to the nearest tenth of a meter. The nearest tenth. I get x is approximately equal to 202 point to 10th meter, where that would be a 1. So they're off by 0.1 there, but that is the closest answer. So, and I did not round. They must have rounded when they did theirs. But anyway, so that's the answer, and that's how you do this problem.